Good morning, ladies and gentlemen. Today we want to study first-level gens, the axioms of induction, in greater depth, with particular emphasis on how we come to learn and objectively validate them. And I want to start by noting that all gens, first level and higher, are statements of causal connection. All assert or imply that an entity of a certain kind necessarily acts in a certain way under a given set of circumstances, which is the essence of the law of causality. This is true on all levels of development, from pushing a ball causes it to roll, on through a net force exerted on an object causes it to accelerate in accordance with the formula F equals ma, and so on. If we leave aside Kantian subjectivism, there is nothing to unite two existence, such as pushing and rolling, or force and acceleration universally. In other words, there's nothing to make any generalization true except some form of causal tie or relationship between the two. The only basis for inferring the future from the actions of the past is the fact that the past actions occurred not arbitrarily or miraculously, but for a reason inherent in the nature of the acting entities themselves. In other words, the basis is that the past actions were effects of causes, and same cause tomorrow, same effect. Any validation of generalizations, therefore, must answer the question, how? By what means does man learn causal connections? And today I'm going to deal with this question only as it applies to first-level gens. Now, an essential precondition of a man's discovery of particular causal connections is his grasp of the general law of causality. If anyone lived, or thought he lived, in a Humean universe, he could not raise or answer the question why about anything without the fact and the knowledge of the law of causality, both the fact and the knowledge of that fact. There would be nothing but a flow of brute, disconnected, random data. The knowledge of the law of causality is first gained by a child in implicit form, in the early preconceptual stage of cognition. This is stuff straight out of Opar, which I'm reminding you about. It is grasped as a corollary, a self-evident implication of the law of identity, which of course is one of the fundamental axioms of philosophy. The implicit knowledge of both these laws is necessary to any further cognitive development. Only when a man knows the law of identity can he at a later stage go on to understand and ask the question, what is this thing? In other words, what is its identity? Similarly, only when he knows the law of causality, at least in implicit form, can he go on later to understand and ask the question, why? i.e., what is the cause? Now that's general philosophic background. But assuming now the necessary metaphysical foundation, the question we want to answer is, how does a man come to discover particular causes? Specifically, how does a first-level inducer grasp his first causal connections, and thereby gain an explicit grasp of the concept cause? Now we're considering here a child or a primitive who induces on his own, not one who accepts a gen on the authority of other people. A child's first causal discoveries, I believe, flow from his experiences of his own personal efficacy. I'll repeat that. A child's first causal discoveries, I believe, flow from his experiences of his own personal efficacy. Now, this is only a likely and unoriginal hypothesis. I've found many other people in preparing for this that believe that. Even if it's not universally applicable, it indicates at least one possible common pattern of development. Now, here's how it would work. A toddler, say, pushes a ball and it rolls away. How do we formulate? Now, we're using adult conceptual terms. But how do we formulate what the child actually perceives using his eyes without benefit of language? And here are three ways as adults we could formulate the same one fact which the child perceives without benefit of language. I roll the ball by pushing it. My pushing it made the ball roll. I caused the ball to roll by pushing it. Now, these three formulations are logically equivalent. Each entails the other. Each identifies the same self-evident fact, but from slightly different perspectives. Only the third statement, I caused the ball to roll, mentions the concept of cause. But the content of that concept is already present in the others. It is present in the very meaning of rolling an object. To roll an object is to cause it to roll by a certain means. The experience of rolling a ball, therefore, is the experience of causing something to happen. It is a pure experience of causation, without some equivalent of which, it seems, the concept of cause could never be reached. So I am saying in this sense that the concept of cause is directly ostensive. In the act of pushing the ball and observing the fact of rolling the ball, which you can observe without language, you are observing yourself making something happen. That means you are observing an act of causality which enters your mind without benefit of language, which means causality is a perceptual phenomenon. Just as one perceives an intransitive rolling directly, you know, the ball is rolling. That's the intransitive use. And you can just see a ball rolling. So, and I think exactly so in the case of a transitive rolling. I rolled the ball. You experience it directly. And if such rolling is an object of direct experience, as it clearly is, then causing too is an object of direct experience. I'll give you another example. The toddler, thirsty, drinks a glass of water, and his thirst disappears. What does he perceive? Not state, because it may be before the use of language altogether, but perceive. Well, it amounts to this in adult terms. I stopped, or got rid of, slaked, quenched, you can fill it in. I stopped my thirst by drinking water. Or, my drinking water made my thirst go away. Or, I caused my thirst to go away by drinking water. Again, the content of cause is present in the experience itself. The quenching of one's thirst is an object of direct, introspective experience. And it is an experience of one thing causing another, since to quench is to cause a certain effect. Thus, the experience of the quenching is the perception of the causing. That's not too hard to grasp, right? Okay. In these cases, and there are countless similar ones, a child, contrary to David Hume, does experience a connection between certain events and not merely a conjunction. It's not as though, as Hume says, first there's the drinking, and then as a big surprise there's the absence of thirst, and the two just happen to go along together. On the contrary, the child experiences the connection between what he does and what it makes happen. In this case, between the drinking and the quenching of the thirst. And this is the basis of a child's first level gens. And it gives him all the explicit knowledge of cause necessary for further progress. This is where I would start out the mind in its grasp of specific causes rather than just the abstract, implicit causality that you get from metaphysics. Now, at a certain point, a child moves beyond these early experiences to start to discover causation in the external world apart from his own action. But I hold that he uses the same method in doing so. Armed with an explicit concept of cause now. In other words, of one thing making another happen, which is all the concept of cause comes down to. The child is ready to perceive all around him further instances of it. I make the ball roll becomes in due course the wind makes the leaves flutter. The fire makes the paper turn into ashes. The rain makes the ground wet, etc. In all such cases, the causal connection is grasped from a single instance because we directly perceive the causation as it is occurring. Just as we perceive, without the need of language, rolling the ball, so we perceive blowing the leaves on the part of the wind, burning the paper, dampening the earth. All of these terms, blowing, burning, dampening, denote objects of experience which are causal processes, processes in which one thing makes another happen. So I'm prepared to go this far and say the primary method of grasping causal connection is to perceive it. The primary method of grasping causal connection is to perceive it. Now, building on this foundation, scientists develop more sophisticated experimental methods of discovering causality in cases where perception of it is not possible. And the use of such methods requires an analysis of variables going far beyond the first level of cognition. But in regard to first level gens, which is our concern here, that's what we're talking about, direct perception of cause and effect is essential and sufficient. Now it follows from this that a sheer observation of a regularity without any grasp of its cause does not establish a gen. I think we mentioned this in the question period yesterday. However often, as an example, primitive man observes the sun traveling in an arc from east to west, he cannot on such basis alone generalize. If he has no clue as to why it's happening, no beginning of an explanation, no sniff of causality, even in an early primitive context, his perceptions are rather than the first evidence he has for a gen, but it can be validated only by reference to later knowledge based on other methods. For instance, the knowledge and methods of Copernicus and Galileo. Here again we see that quantity of instances alone is irrelevant to induction. In first level induction, a single instance is all there is. It is necessary and sufficient. By contrast, thousands of observations of a disconnected regularity establish at most a hypothesis worthy of investigation. Now I have to point out here that I've been assuming in the above a firm distinction between two forms of grasping causality. In personal terms, through one's own efficacy, and then, in regard to the external world, impersonally, without reference to anyone's efficacy. But this distinction, so clear to us today, had, like virtually everything else in philosophy, to be learned, and it took many centuries. When they turned to cause and effect in the external world, primitives, and even children left to themselves in our civilization, typically continue to construe the causal processes they perceive on the model of their early personal experience. Projecting their own pattern outward, they think of causal agents in the external world, some or all, as being personal entities, and to construe causation as the expression of their inner desires or intentions. The obvious historical example of such anthropomorphism is the animist idea that even inanimate entities are ensouled things who act with ends in view. Theism maintains the same view of causality, merely consolidating the multitude of ensouled causal agents into a relatively few efficacious persons, or even if the theist is ambitious, into a single omnipotent one. And you know his name. In this respect, religion represents the mind and metaphysics of primitive man. Such a mind has little or no concept of an impersonal material world, one in which the action of external entities flows not from souls or desires, but from the law of identity. In other words, from the physical nature of the acting entities in the absence of any consciousness, whether immanent or transcendent. The impersonal metaphysics was the great and historically recent achievement of the Greeks, specifically of Aristotle's secularism and advocacy of reason. It was this approach that led to the clear Greek distinction between the animate and the inanimate, which included the fact that consciousness can belong only to the animate. Once the Greek approach was embedded in the mind of the West, and leaving aside such relapses as the Middle Ages, causation could no longer be conceived in terms of the personal efficacy of supernatural agents. And thus the objective view of cause and effect displaced the anthropomorphic view that at the beginning had seemed to be merely an innocent extension to nature of men's own causal experience. So what Western civilization did is broaden the concept of cause by regarding personal efficacy as merely a subtype of it. And this was a crucial precondition of the development of modern science. It amounts to bringing causality for the first time fully into the realm of reality and identity. In other words, to springing its primordial bonds to mysticism. All right, let's go on to the next point. This point is clear so far? We grasp causality on first level instances by direct perception. But we need another step before we can validate first level gens. Because percepts as such reveal concretes, not abstractions. Percepts reveal Tom, Dick, and Harry, for example, not man. By perception alone, therefore, the first level inducer grasps causal connections only in concrete terms. as a relationship at a specific time and place between two or more particulars. For example, he perceives that his act of pushing just now caused that ball to roll. Or he grasps, to change the example, that the flames in the fireplace over there this morning burned that particular piece of paper. Now, such observations obviously are indispensable as the start of an inductive process, but they are not yet generalizations. What turns them into generalizations? This is our question. What mediates the passage from a causal connection linking particulars to a universally applicable truth? You get that question? What mediates the passage from a causal connection linking particulars to a universally applicable truth? By perception, we get a concrete causal relation, linking this particular to that one, this pushing to that rolling, these flames to that paper burning. How do you get from that to a universally applicable truth, a generalization to what all pushing does or what all fire does? Now, the answer has to lie in man's distinctive means of dealing cognitively with particulars. And what is his distinctive means? Concepts is conceptual faculty, because the essence of concept formation is the passage from particulars to universals. Now, I remind you again that a concept in Ayn Rand's theory is an integration into a single mental unit of an unlimited number of particular existence. And the integration is possible because the existence in question possess the same attributes. They differ from one another only in what? The measurement of these attributes. So by dropping, not specifying, the measurements, the mind can form a new unit which includes and applies to all such existence, past, present, and future. And thereafter, the mind retains and deals cognitively with this unlimited sum by means of a single word, assuming it's appropriately defined. A concept, in short, is the identification of a group of perceptual concretes with their measurements omitted. Now, that should all be a bromide to you. Now, let's follow up in our context. In the nature of the case, therefore, when a concept is formed, only some of the instances in the subsumed group have been perceived by man. Only some. New instances are conceptualized, in other words, placed under the appropriate concept as and when they are encountered. And this is man's method of connecting new percepts to previous ones, and thus of applying to them any knowledge already gained about the members of the group. That's the human pattern. Like any developing young mind, therefore, the first level inducer is eager to use his simple vocabulary, simple first level concepts, his simple vocabulary to name new objects which he recognizes. In regard to the present issue, he is concerned to identify, in terms of the vocabulary available to him, the elementary causal connections he directly perceives. He is not content mutely to observe that that thing over there caused this one here to blacken and disappear. He can name the entities and processes at work by applying concepts he has already formed, such as fire, paper, burning. And of course, now follow me here, it's going to be over before I start. In utilizing concepts as his cognitive tools here, he is thereby omitting the measurements of the particular causal connection he perceives. In utilizing concepts as his cognitive tools here, in naming it in conceptual terms, he is thereby omitting the measurements of the particular causal connection he perceives. The word fire, when he uses it, relates those orange flames over there, the ones he perceives, to all such flames, regardless of their varying measurements. And the same applies to paper or to the process of burning. Hence, his first statement of his concrete observation is fire burns paper. That's his first statement when he applies concepts to the particular concrete he perceived. And this statement is simply a conceptualization of the perceived data, which is what makes us call it a generalization. Now observe that our inducer is not and cannot be what philosophers call a nominalist, which amounts to somebody scornful of abstractions. When he first identifies a perceived causal connection in words, we're talking about a child now, he does not do it as a description of unique concretes, even though that is all he perceives. Let me say it again. When the child first identifies the causal connection that he perceives, all he perceives is the unique concretes interacting causally. But he does not describe it as a description of unique concretes. He at once states a universal truth in the act of naming the concrete causal connection he's perceiving. What would the alternative be? It would be a young toddler seeing a fire burn a piece of paper and saying something like this: I see shimmering yellow-orange, smoke-emitting flames about 3 feet high, turning that huge front page of the newspaper with its big black headlines into a small pile of hot white ashes. Now, obviously, no toddler in the world could speak like that, certainly not when he's grasping first-level gens at the very beginning and has only first-level concepts. He doesn't begin to have the conceptual apparatus necessary to distinguish in words one instance of fire-burning paper from another. First, he must grasp that what he sees is an instance of fire-burning paper. In other words, of concepts he already has. Only much later, when the vocabulary identifying specific measurements of fire and so on has been reached, can he use words in sophisticated combinations to describe the action of a unique fire. And therefore we have an inexorably true but seemingly paradoxical statement. Logically, the generalization must come first before you can describe the particular causal connection, the perception of which underlies the generalization. The generalization is the direct product of applying one's conceptual apparatus to the perceived connection. The generalization is the direct product of applying one's conceptual apparatus to the perceived connection. And that's why the child's first remark on the subject is simply, fire burns. Now let's take one of our other examples. A toddler sees a particular ball, which he identifies as simply ball. At this early stage, he obviously doesn't and can't know any wider integrations or subtypes or cross-classifications of ball. He cannot identify a ball as a human artifact, or as a red golf ball, or as a product of capitalist profit-seeking. To him, at the start of the conceptual process, the verbalized object is ball, pure and simple, and nothing more. And the same applies to the child's experience of himself as the particular pushing agent. His identification at that stage has to be of pushing as such, not of voluntary human action, nor of exerting force, nor of my own individual act of pushing as against everybody else's, since he does not yet know any such relatively more abstract terms. The concept simply denotes to him any and every act of pushing, regardless of the agent doing it. And now we said he only observes the pushing at a given time and place. But that's obviously also an irrelevancy to the child, and should be to anyone, because inherent in forming and applying a concept is the understanding that what counts cognitively is only the identity of its reference. In other words, the mere passage of time, or the mere change in location, assuming everything else remains the same, makes no difference to one's conclusions by the very nature of a concept, because the concept of an existence subsumes all instances everywhere, past, present, and future. So let us sum up here this point. Because of his simple first-level conceptual structure, our inducer, in the very act of naming what he perceives, automatically drops the measurements of the perceived cause and effect, and thereby gains knowledge transcending the given concrete. This is how he is able to grasp that the cause pertains to pushing as such and the effect to balls as such, no matter where or when they're meeting. Do you get that point? Now, if we judge by their actions, animals too have a direct experience of causation. They too perceive that various actions they take make certain things happen, but they cannot go on to infer any gen from these perceptions. The crucial difference here is that animals have no conceptual faculty, no faculty of omitting measurements. So they cannot set aside the particularity of any perceived data. They have no cognitive power, therefore, to separate what counts in a causal situation, for instance, being a fire, from what does not count, for instance, the exact shade of the flame, the area of the paper, etc. What does not count is the measurements, which in the context at conceptualizing mind discards implicitly or explicitly as irrelevant, mere detail, non-essential. Animals, as a result, cannot project from their percepts what future to expect. But this is what man does in the sheer act of conceptualizing a percept. So if you want to take this down, this is not a definition, but this is like a metaphysical fluoroscope. A gen, in essence, is no more than the percept of cause and effect conceptualized. Or if you want to put another way, induction is measurement-omission applied to causal connections. It's nothing more or less than a form of the essential method of concept formation. Just as a concept, through measurement-omission, integrates an unlimited number of particular existence into a single word, so a certain union of concepts through measurement-omission integrates an unlimited number of particular causal sequences into a single proposition that subsumes them all, and that's a generalization. Now we can sum up in regard to the axioms of induction. When a first-level inducer identifies his concrete experience of cause and effect in terms of words, when he does that, his perceptual grasp of the causal tie becomes thereby a conceptual grasp of it. In other words, a generalization. And since the application of first-level concepts is automatic and self-evident, the two aspects of a first-level gen, the perceptual and the conceptual, are each to a human mind self-evident. You got that? There's two aspects, but they're both self-evident. One is self-evident because it's perceptual, and the other because you're using only first-level concepts, the application of which is self-evident. Hence the conclusion. There are at the base of all future induction absolutely certain first-level gens which extend beyond all possible perception and which follow self-evidently from man's highly limited perceptual experience as and when this is processed by his conceptual faculty. Now that, I think, is a good answer to the question, how do you validate the starting generalizations on which the whole process, the whole inductive tower is going to be based? Because it establishes the role of both perception and conception and explains clearly how we can reach this knowledge of the entire universe on the basis only of what we perceive. Now I have a final topic which is more difficult, but is also illuminating and follows directly from what I've said. Now, since I didn't say any of this last year, I couldn't do the follow-up, but this year it occurred to me, having got that far, that there's an even more significant point that you could go to. And that is, let us turn again to the topic of induction versus deduction. We already said that the standard definition, let me not get the wires caught here, that deduction applies a generalization to an instance and induction goes from instances to the generalization. But I want to look much more profoundly at what is the difference between induction and deduction and why there's always been a problem of induction and never been a problem of deduction. And now I'm not restricting myself to the first level anymore. I'm using that just as a key to the whole topic. So we're going to penetrate to the essence of inductive reasoning on any level, which we have not yet done. So let's first start with what is reasoning. Reasoning of any kind. And obviously it's the process of inferring a conclusion from earlier knowledge. In valid reasoning, you start off with certain premises, but they are not the takeoff point for a flight of imagination, for a guess, a hypothesis, or an arbitrary leap. In reasoning, the conclusion follows from the premises necessarily. Underscore that. Follows means, follows necessarily. It means if the premises are true, the conclusion has to be true. If it does not follow necessarily the conclusion, then what do we call the argument? A non sequitur, and the inference is invalid. Now I'm starting with that as the definition of all kinds of reasoning, not merely of deductive reasoning. Any kind of reasoning is inference of conclusions from premises. And inference means, given these premises, the conclusion has to follow. Now, Ayn Rand defines logic as the art of non-contradictory identification. In other words, if you deny the conclusion of a logical argument, you would be contradicting the earlier information in the premises from which the conclusion was inferred, and thereby would be violating the law of identity. And since we know a contradiction is impossible, if the premises are true, the conclusions in question must be true. Now, I am going to affirm that this is the pattern and principle of all valid reasoning, whether it's deductive or inductive. Now, the application of this principle to deductive inference is straightforward. I say parenthetically, I am not talking about mathematics today, because how my discussion applies to mathematics is a separate, complex topic about which I won't even entertain question. And I'm saying why this is straightforward and easy as applied to deduction. In applying a generalization to a particular case, we are making explicit in the conclusion information that was included implicitly in the premises from the outset. In this sense, a deductive conclusion contains nothing logically new. That is why, in deduction, it is self-contradictory to affirm the premises and deny the conclusion. For example, I couldn't reason as follows. All men are mortal. Socrates is a man. Therefore, Socrates is not mortal. Because that would be tantamount to saying all men are mortal, and here's one who isn't. In the valid syllogism, by contrast, when I conclude that Socrates is mortal, I am doing no more than remaining true to my initially stated premise. But now the situation in regard to induction is more complex. If I reason from the mortality of Tom, Dick, and Harry to the conclusion that all men are mortal, my conclusion here is something new. It is not implicit in the data about the named individuals. Here it is not a matter of merely remaining true to what I have already laid down. And hence we have this problem. Why is inference in this direction? In other words, from some to all, or from particulars to a generalization, necessary? Why must a generalization follow from information about one or more of its instances? And we said that logic involves non-contradictory identification, and if you reject the conclusion, you're involved in a contradiction. Well, what contradiction would we be embracing if we accepted the information regarding the observed individuals and yet denied the generalization? Do you get that question? What contradiction would we be embracing if we accepted the information regarding the observed individuals and yet denied the generalization? Now, by my study, no satisfactory answer to this question has ever been offered in the history of philosophy. As a rule, the attempt to explain the logic of induction has taken the form of attempting to reduce induction to deduction. Aristotle is a good example here. In his view, induction merely suggests gens, which, to be validated and thus become knowledge, must then be deduced from broader gens, a process that he thinks continues back until you reach the broadest gens of all, which are supposedly self-evident. For example, on this view, our experience with Tom, Dick, and Harry merely suggests that all men are mortal. But one then proves this last by deducing it from the gen that all living organisms are mortal, etc. So on Aristotle's view, a general truth is known either as a self-evidency or by a process of deduction from such self-evidencies. Induction he does not regard as an independent form of reasoning or of proof. Now that is really a Platonic element in Aristotle's thought, but it soon became the staple of rationalists, many of whom discarded induction even as a suggestive preliminary. Now, in reaction to all this, the empiricists, of course, justifiably denied as floating and mystical the rationalists' deductive castles. But they nevertheless agreed completely that induction is not valid reasoning, but merely a blind leap is their favorite word, a leap in the dark, which they saw cannot be the foundation of reliable knowledge. So the empiricists ended up as skeptics. The challenge to logicians and philosophers is to identify a form of reasoning hitherto unacknowledged, a form of reasoning in which the conclusion follows from the premises necessarily, but not deductively. You get that? Now, most philosophers wouldn't even grasp that as a question because they equate necessity and deductive. And therefore, they don't even know what you would be asking, let alone answer it. But we're talking about a type of case in which the conclusion does state something new, something that goes beyond all earlier knowledge. It's definitely not deduction. And yet that same conclusion, given the earlier knowledge, is inescapable, compelling the mind's acquiescence on pain of self-contradiction. Now, on the face of it, that is a real conundrum. How can something go beyond all earlier knowledge and yet be so inescapable that you would be contradicting that earlier knowledge if you didn't accept it? And yet that's exactly what induction is. And you see why it's been a problem. People simply deny out of hand that there could be such a phenomenon. They say that's a contradiction in terms. A necessary and non-deductive inference. And yet that is what induction is. And I think the lead to the answer to this problem is found in the study of first-level gens. And that you already have in your possession all of the tools necessary to answer this hugely important question. Because as we have seen, there are two elements involved in validating a gen. The grasp in a concrete form of a causal process and the conceptual identification of this process. This combination, as we have seen, is what validates a first-level gen. And I want to see now whether and how this pattern might apply to complex, higher-level gens, and then see what broader conclusions we can come to about what really is induction. What do we really do when we validate a gen? But let's look first at whether those two elements, the perceptual and the conceptual, whether and how they apply on higher levels. So let's turn to a case typical of scientific induction, in which we do not directly perceive causal connections, and in which we are not restricted to a handful of first-level words, but rather depend for our identifications on a multitude of advanced concepts. And we may take as an example here, and it was suggested to me by Dave Harriman, Benjamin Franklin's famous Kite Experiment. Franklin set out to prove that lightning is essentially electricity. Thunderclouds, he hypothesized, are electrically charged, and lightning is merely an electrical discharge when the charge runs off to the earth. Now, scientists do not always have their explanation of events worked out as a hypothesis in advance of their experiments. But sometimes they do, and Franklin did in this case. And he set up his apparatus accordingly. He flew a kite during a storm, of course, protecting himself inside a shed, guiding the kite by holding a non-conducting silk ribbon tied to it. A pointed wire jutted out from the top of the kite, and the wet kite strings, they were wet because it was pouring rain, the wet kite strings at the bottom were tied to a metal key which touched a wire going down into a jar, a Leyden jar, which is a kind of condenser in which you can store electrical charge. Now, if Franklin was right, electricity in the thunderclouds should jump to the pointed wire, then travel down the wet strings to electrify the metal key, and thereby flow through the adjacent wire and accumulate in the jar. And of course, it's not a surprise to you that everything he predicted turned out as he expected. And he concluded he had experienced one thunderstorm. He concluded with a sweeping and necessary generalization describing the nature of lightning as such, everywhere and always. Now let's try to trace why was his generalization necessary given his observations, although he saw only one thunderstorm. Now, first, the observational or perceptual element. What did Franklin actually see during this experiment? What concretes did he observe that could also have been observed by a child or a savage? Well, among other things, he saw sparks flying from the key to the wire in the Leyden jar. And he saw pieces of the wet kite string become rigid and repel each other. He observed that if one holds a metal object up to the jar, sparks are drawn out of it. And he found that if you hold the jar with one hand, while touching your finger to the wire entering it, you get a bad shock, which didn't happen before. Now, all these concrete observations are essential to the experiment. You could learn nothing without them. Yet these observations would be meaningless to an ignorant person. A series of sparks and shocks would communicate no causal sequence to a child or even to an ordinary educated adult at Franklin's time. Of course, there is a causal sequence at work here, but it is not perceivable as such. Another element, therefore, is necessary before Franklin can grasp the causal sequence and validate his generalization. Besides his percepts, what did Franklin need? A whole series of sophisticated concepts. Otherwise, he could neither have thought up his experiment nor interpreted its results. For example, he would have been helpless without such concepts as electricity, discharge, conductor, insulator, condenser. Without that, he couldn't have conceived his experiment, let alone interpreted it. And all of these concepts, of course, were made possible by and represent a wealth of earlier knowledge. Without this conceptual framework, I want to call it, a conceptual framework, Franklin could only have stared like a child or a savage, uncomprehendingly, at sparks and shocks. But given such a framework, he can at once identify what he is seeing using those concepts. He can utter to himself a thought like, electricity is discharging along a conductor into an insulated condenser. He's covered exactly what he observes using a whole framework of advanced, sophisticated concepts, which enables him to identify exactly what is happening. And once Franklin can identify what he is seeing in such terms, his conclusion, the gen, follows directly. The conceptual framework enables him to identify, with their concrete measurements omitted, every aspect of the causal chain. Nothing else known or even rationally conceivable explains the observations. So the conclusion must be that lightning as such is an electrical discharge, which is a generalization. In other words, if one grasps the observations in this case and knows that the conceptual framework is valid, then the generalization follows necessarily. Necessarily. Its denial under these conditions would involve a contradiction. If you denied Franklin's generalization, you would be contradicting either his direct observations and or a valid conceptual framework. But if you have both of those, there is no escape from his conclusion. Whether we speak of first level or advanced induction, therefore, the same two elements are involved. The grasp of a causal process through concrete observations, and the use of concepts to identify. The main difference between beginner and scientist lies in the complexity of the requisite conceptual framework. The child knows only a handful of concepts, like fire or paper, which he defines ostensively, and which are not yet logically connected to one another in his mind. But as concept formation progresses beyond the first level, a cluster of unrelated concepts is no longer adequate. I think, if you remember OPAR, I've shown there that concepts must eventually become aspects of one integrated system of concepts, one integrated conceptual framework. You remember the part about knowledge is a sum, a unity, and no concept can be valid until it is integrated into that unity. As if you had a free-floating, disconnected concept, it would have no context in the rest of your knowledge and thus no tie to reality. So the conceptual framework essential to Franklin's experiment extends far beyond the handful of technical electrical concepts I've so far mentioned. Precisely because all knowledge is integrated, electrical knowledge cannot stand in a vacuum as a self-contained cognitive department. In order fully to understand the electrical concepts he was applying, and in order to know that these concepts, as against any others known, are the only relevant ones, the only ones that identify and thereby explain the facts in this case, Franklin needed access to the total of his knowledge, including the vast body of information from other fields outside of electricity and its manifestations. In short, if integration is a requirement of logic, as I said in OPAR, then in higher level induction, the proper conceptual identification of a causal process requires the knowledge and use of one's total conceptual framework. Now it is instructive to recall here the origin of Franklin's hypothesis in regard to lightning. It did not come to him like a thunderbolt out of the blue. He began by listing 12 observed facts relating lightning to everything from any department of his knowledge which was conceivably relevant to understanding its nature. And these facts ranged all over the map of cognition. They related lightning to light, to color, to velocity, and thus implicitly to dynamics, to the behavior of metals, and thus implicitly to chemistry, to the knowledge of different kinds of substances, to sound, to heat and temperature, to smell, and even to animal life and death. Having surveyed this vast, sprawling cognitive territory with no compartmentalization, no barriers anywhere, he found data everywhere suggesting that lightning might be electrical. So the next step to take, he concluded, was obvious. And this is his famous quote, "Let the experiment be made." In short, correctly to identify his observations in this experiment, he needed to survey the sum of his knowledge. He needed to integrate lightning to everything known that might be relevant to its nature, whether or not any given item of knowledge was officially included in the study of electricity. He needed not just some specialized or technical concepts, but a total conceptual framework. A total conceptual framework. So to summarize, the structure of inductive reasoning in general, on any level, is observation, the application of one's total conceptual framework, and therefore necessarily a generalization. Should I repeat that? This is the structure of inductive reasoning on any level. Observation, the application of one's total conceptual framework, and therefore necessarily a generalization. And now I think you can see the real fundamental contrast between induction and deduction. It has nothing to do with the silly idea that induction is merely probable or that induction involves some kind of arbitrary leap or any of the nonsense that our philosophers tell us. Deduction is a simple form of reasoning. It starts with a causal connection already conceptualized. All men are mortal, for example. Already formulated as a gen. In other words, deduction starts with a complex conceptual product regarded as established and unproblematic. The deducer is not as such concerned with the process of conceptualizing complex data. He takes for granted from the outset that we have solved all the hard epistemological questions involved in forming and using concepts. He takes as a given that the conceptual faculty has been used to gain profound new knowledge and that it has been used properly. And he then proceeds to milk the new knowledge for its implications. Deduction takes for granted the process of conceptualization. Induction is the conceptualizing process itself in action. Let me repeat that. Deduction takes for granted the process of conceptualization. Induction is that process. It's the conceptualizing process itself in action. What produces the gen is the application of a conceptual framework to perceive data. So an inductive argument is not a self-contained series of premises from which the conclusion follows as a matter of formal consistency. The reason is that the bridge from observation to generalization is not one premise and not even 100 or 1,000 premises. The bridge between what Franklin observed and what he concluded cannot be stated in any specific number of premises because the bridge is the total of his knowledge properly integrated. And you can't quantify that as 75,000.9 premises. There's his observations, there's everything he knows, the total conceptual framework. And put those two together, the generalization follows necessarily. And you see why induction, therefore, is so much more difficult and controversial than deduction, and why it is not reducible to the formalism of symbols. Deduction says, given one specific relation of concepts, for instance, the relation between man and mortality, then X, the conclusion must follow. Induction says, given the entire system of concepts, then X, the conclusion must follow. In deduction, the conclusion is necessary. Otherwise, you negate one specific product of the conceptual faculty, one specific gen. In induction, the conclusion is necessary. Otherwise, you negate the whole system of human concepts. In other words, the sum of knowledge gained by man's reason. In other words, the rational faculty as such. You get it? The problem of induction has been insolvable for so long because the nature of human consciousness has been misunderstood for so long. To solve the problem of deduction, one must grasp that A is A, which is Aristotle's monumental achievement. But to solve the problem of induction, one must grasp another monumental achievement, Ayn Rand's theory of concepts. And now, at last, we have it. Thank you. Thank you very much. So I lived up to my brochure description as a 70% new, right? Now I want to start this question period by asking Greg Salmieri to stand, because I want to offer him a public thank you. This lecture is essentially owing to him, or at least the first germ of it. When I presented first level gens and how they were validated in the course last summer, I was all gung-ho at that point on the experimental method. And when I analyzed pushing a ball makes it roll, I'm embarrassed to say this now, but my analysis was it was really an experiment using the method of difference. The kid sees the ball roll, and the only difference he notices is that his arm moved forward and back, and therefore he infers that his arm must have been the cause of moving the ball. His pushing must have caused the ball. And in the question period, which was very abbreviated because those lectures at that point were 2.5 hours long, so we just had 1 or 2 quick questions. And Greg got up and said, isn't it possible that the child actually, words to the effect of experiences the causal relation in his efficacy in pushing the ball? And I said something cavalier and dismissive as to why that couldn't be true. And he was very polite and sat down. But if I've learned anything, it's that I keep my subconscious open, and even after I've said no, if there's some element of doubt, it germinates in there. And of course, my wife in this case, Amy, helped a lot because she thought what he said made a lot of sense. So she was after me, and I had my own doubts, and between it all, it suddenly occurred to me, well, maybe he's right, but then, and then I had to think what the implications of that would be. Then that would have to mean we perceive causal connections, but how could you perceive a causal connection? And I had to work that whole thing out, and then I said, but that wouldn't be a generalization. So then I had to work that whole thing out. I said, now I think I have the clue to induction versus deduction. So it really went back to your suggestion, and I want to thank you publicly. And if and when this is ever published, I'm certainly going to mention you're putting me in the right direction. So thank you very much.
I don't have a...
Well, you should get a chance first.
I don't have a question really yet. I don't know what to say, but I guess you're welcome, and thank you for telling me all of this.
Okay, I'll take that. I hope you didn't dismiss the idea because I did.
No, actually, I followed up on it, and I think had some ideas that I'd like to talk to you about sometime.
Okay, absolutely.
That are, I think, similar. So.
That's the least I can do.
Okay, well then, again, thank you.
Okay. Yes.
Thank you, Dr. Peikoff, for that historic lecture.
Thank you.
I may be mistaken, but I think if Einstein was here, his reaction would be, he doesn't actually know what gravity is, in the sense that you're challenging us to do, and that if I understand it properly, his whole theory of his whole general theory of relativity is more along the lines of the idea that you spoke about, the sun coming up every day. He was just looking for numerical patterns.
Well, I don't want to comment on Einstein specifically because he has said different things on the subject of causality. But I'll talk certainly about the approach of modern science to all these questions, and this is covered extensively in Dave Harriman's upcoming book on the anti-Copernican revolution, where he shows what modern scientists do when they allegedly practice science and what the philosophic roots of that is. But what it amounts to is they make up a mathematical symbolism out of the blue, simply arbitrarily. And then they apply it to some existential situation and find that somehow, for no reason that can be specified, certain mathematical formula work to enable them to make successful predictions and others don't. And they keep those formula until and unless something comes up which it doesn't predict, and then they tinker with the formula. And if you ask them, is this what is the cause of the particular event that you're observing, they would utterly throw out the idea of cause and effect. These are just phenomena succeeding one another. They have no cause. There is no logic to their behavior except some arbitrary mathematical sequence. So it's the total opposite of everything that I've said. They don't believe the generalizations are based on observation at all. They believe it's Kant is their model. You know, for Kant, the basic concepts do not come from observation the way they do for Aristotle or for Ayn Rand. They're built into the mind. And then you interpret everything in accordance with those concepts. that is the model that all modern science uses. So there's no such question as finding a causal explanation for why something in reality happens. They won't even accept the idea of reality. I remember studying Einstein years and years ago in undergraduate school. I remember nothing except one thing. We had a textbook, and you know they were presenting those three paradoxes of Einstein, that if you get to the speed of light or near the speed of light, what is it, length contracts or expands? Length is supposed to contract. And the textbook raised the question, it may be asked whether length really, and he put really in quotes, contracts at the speed of light. The answer is that physicists are not concerned with what, quote, really happens, but only with observed quantities. So, I mean, so any practicing scientist today who is at all theoretically inclined would have walked out within the first 10 minutes of my... As soon as I invoked the law of causality, he would be gone. That's about all I want to say on that.
So many scientific theories today are merely just elaborate hypotheses?
I wouldn't even give them that much dignity. They're arbitrary constructs. It would be just the same as if I had a dream that if you run around a teacup twice and then pull your hair out, the pattern of leaves will tell you your income 3 years from now. And then it worked. Say, well, that's my science of tea leaves. And I'd probably get a huge grant from the government and a tenure track position at Harvard. Amy.
Thanks for the lecture. I'm glad I didn't know you were working on this while I was writing my dissertation, because it would have been more interesting. Here's the problem that I'm having understanding is between the direct grasp of causation that a child will have rolling the ball, and then bridging that to the impersonal causation that you are going to see still on the first level, but out there. And I was wondering if you would say that impersonal causation, which a child directly perceives, say falling down or something like that, could help bridge that. What do you think? So impersonal causation that
on his own body,
right, or some other impersonal causation that is nonetheless directly perceived by the child because it affects him in a way that is directly sense perceptible.
That's possible. I wouldn't attempt to prescribe the stages by which you go from one to the other. All I'm interested in is saying there's this type and there's this type. But what stages you may have to go to as transition, I wouldn't know. I haven't done enough thinking in that field, and I don't think it would be of philosophic significance. You know, there's a real problem in concretizing the theory I put forth, but it's an analogous problem to the problem that objectivists face in deciding what is a first level concept. If you look up in the appendix of IOE, you'll see that various professors question Ayn Rand on why is table a first level concept, but dining table is a subdivision, you know, and she has to give very detailed guidelines, and she says in certain cases it's optional where you start. You remember her example, if you're born in a furniture store,
yeah.
And that's all you know, it may very well be that you distinguish dining tables from living room tables as your first conceptual distinction. So the definition or the delimitation of what is a first level is itself tricky. You have to specify the context and where there are options. All I'm laying down is that there are obvious first level instances and that's enough to grasp the theory. But in any particular case, it can be very complex. Dave and I had long discussions over particular things. Would this be a first level or not? And then if it is a first level, is this a good one to present to a class, or will they get so confused by the complexity that they won't get its first levelhood, so to speak? So we finally whittled it down to clear-cut cases, but I don't know that a great deal is to be gained any more than in the theory of concepts by multiplying examples once the idea is clear.
Okay, thanks. Can you just comment briefly on the book status of this material?
You mean, what's the status of the book?
Getting this written up in book form.
Yeah, well, what I delivered yesterday and today is the first 2 chapters of a book based on this whole course called Induction to Physics and Philosophy. But it was extremely difficult for me to do. I was in constant consultation with Dave Harriman over things like the Franklin example, or how you reduce Galileo to first-level concepts, etc. And it occurred to me that if I'm not dependent on Dave for the philosophic intro, what's going to happen when I try to write the rest of it? So I asked Dave if he would be a co-author, and in fact a dominant author of this book, and I would be available to write passages here or there, or for consultation, editing, etc. We'll bring it out as a joint project. And you're still in favor of that, right? Dave has very kindly agreed to do it, so basically the bulk of the work he is going to be doing. And I have a further excuse that I can't sit or stand long enough to do much writing at this time. In any event, that book will go on and will appear, and probably appear a lot faster with Dave at the helm than me. But when it's going to happen, well, we're working on it now. But when we'll get through it all, there's no use giving it a time frame, because when I was writing the Ominous Parallels, people used to think that the title was The Imminent Ominous Parallel. Because it was imminent for 14 years. So that's the best I can say. Yeah. Christine, is that you?
Yes.
Yeah.
Hi. I think it's so brilliant that it's almost self-evident. I mean, it's like,
It's
this
what?
explanation is so brilliant that it's almost self-evident. I mean, it's like it was in front of everybody, it was always there, and nobody saw it except for you. So, in any case, I don't know, I see a connection between, and I don't know if it's correct, but between induction and deduction when you do experiments. Like, for example, what Benjamin Franklin could have said in his mind would be, all electrical discharges, if they act this way, they would accumulate in this canister. And therefore, by controlling my experiment, in a way I proved that the lightning is one of those instances. In other words, it was not included, but is that correct?
Yeah, I know what you're saying. You're talking about the hypothetical deductive method, in which a scientist puts forth a hypothesis and then says, if this hypothesis is true, such and such a conclusion would follow observationally. And he then observes that it's true and infers that his...
No, actually, I'm not. I don't even know what you're... No, I don't know. I mean, I didn't mean that. What I meant is that he had, obviously, given the context of all his knowledge, he could say, given all the knowledge he had, he could say that when electrical discharges discharge through this, that the electricity accumulates in this canister. He knew that already from all the context of his knowledge. Now, what he was trying to prove was that the lightning was one of those instances, and so I controlled his experiment, and he said that if this happens, if electricity accumulates in this canister, then there has to be, the lightning has to be
Christine,
one of those.
You have to condense what you're saying into either a question or a statement as to where you disagree, or where you need illumination.
My question is there a connection between, in a way, a deductive statement when you're saying all men are mortals, and therefore this is one of those, I already know this is a man, and therefore he has to be mortal, and this inductive process when you are saying, I know all men are mortal, but I don't know if this is a man, but I'm proving that he's a man, and therefore he's one of them.
That's enough. You'll have to let me take my interpretation.
That's my
now
question.
So you want to interpret, now don't tell me this is wrong, because that's the last one I'm going to You want to interpret Franklin's experiment as follows. All discharges of electricity do so-and-so. Electricity does so-and-so, therefore it's a discharge of electricity.
No, he is proving by his experiment, by his control experiment, that lightning is one of those instances.
We'll have to do it afterwards, because I just can't go on indefinitely. It is not true that he sees this as just an instance and deduces the conclusion. He has to reach the conclusion first that lightning is, quote, an instance of this. That's the generalization.
That's my point.
Well, if that's your point, that's my point. No, all right, enough. Next.
I'm a little unclear on the role of measurement-omission in going from the perception of a instance of causality to the generalization of it. Would you say, is there measurement-omission involved in going to the first level generalization other than the measurement-omission which is already involved in forming the concepts that you need,
No,
such
I
as
said
burning?
there's no further measurement omission, but the measurement omission involved in using and applying those concepts, by the fact of applying them, applies measurement omission to their union, and therefore to the generalization. In other words, it takes the concrete causal sequence, but by putting concepts on it, you are thereby omitting the measurements. It's not as though you have a special act of abstraction of omitting measurements over and above the application of the concepts. But because the essence of the concepts is to omit measurements, the fact of transforming the perception into a conceptual statement shears it of its measurements.
Thank you.
Okay.
Where do Mill's methods come into the picture? You said they're not involved in forming first-level generalizations, but presumably at some level
They're involved as soon as you have to analyze to reach causality rather than perceive it directly. As soon as you have to say, I see such and I infer that such and such must be the cause rather than perceive it directly. And the only way you can infer a causal connection that you don't directly perceive is to say, for instance, well, here was a case that it existed, and here was a case that it didn't. So what differed that could possibly be relevant? And that would be the method of difference, etc. I'm going into those in the next lecture next week on Galileo. I was going to start with how you reach causal connections experimentally rather than perceptual. But that's the next stage.
I'm finding that I think of two things that forming new generalizations may, or problems that may arise, or something that may be helpful. It seems like one thing you have to guard against when people may be criticizing your new generalization is them bringing in some arbitrary thing that you haven't thought of. So you have to be able to reject the arbitrary, that they might want to say, well, what about something you didn't think of? And the other thing is,
unless what they say is correct.
Right. Which is the other thing. You may form a new generalization, but there may be some part of your conceptual knowledge that it contradicts, which may make you check your premises.
Well, that's true of any form of thought and any conclusion on anything by any method. Right. You can make a mistake, but that doesn't therefore inject a note of uncertainty. You have to have specific reason to think you made a mistake. Otherwise, you're going to just be a skeptic.
Right. Well, that's what makes it useful. I mean, you might detect things that you didn't realize
you might
assumed.
Yeah.
Okay.
Well, that's it?
Yeah, well, I was more interested in the aspect of the arbitrary. I mean, isn't that what the critics are going to basically be using to attack this new method? What about all the arbitrary things that you haven't considered?
Oh, I guess so, but I think the critics today wouldn't even get so far as to say you omitted this or that arbitrary possibility. They would just think the whole thing is completely wrong from beginning to end, because I start with existence, identity, consciousness, logic, reason, concepts. You know, all of those things are totally anathema. So you would hardly find a critic who would say, I agree with all that, but I agree with Ayn Rand's theory of concepts, but you omitted so-and-so. I mean, I'd like to see one like David.
Unless I misheard you, I believe you said that the conclusion of deduction is nothing logically new.
Yeah.
And
logically new. Right. Because obviously it's new in the sense that you didn't think of it before, and maybe never even conceived it before. And deduction is an important process of knowledge, which does give us crucial knowledge. So I in no way wanted to defame or demean deduction. I merely wanted to show that there is a difference in the relation between the conclusion and the premises that in deduction you've already implicitly stated your conclusion. And in that sense, it's not logically new. It's already there, although not explicit. Whereas in induction, that's not the case.
I see. All right.
Yeah, there are people who dismiss deduction as completely worthless. And I don't, that's the empiricist type, and the rationalist type dismisses induction as completely worthless. So.
Hi. I want to make sure I understand the Franklin's experiment in terms of what I remember about certainty from OPAR in your certainty lecture.
As long as you don't ask me too much about electricity. Yeah.
No.
Okay.
He sees the sparks. He sees them land in the jar. He sees them come out of the jar. He knows of nothing else that, other than electricity, that would have done that. He knows of no other possible explanation. So he concludes it has to be that the lightning is electricity, because there it is. Is that right? Is that
well? It's that, but it's not as though you make it sound as though he sits back and you say, "Gee, there's three possibilities here. It could be carrot stew, and it could be, so and so, and it could be electricity. But now, given what I know of electricity, so and so and so, it must be electricity." There is here a direct application simply in terms of identifying what he is seeing. If he sees shocks coming out of a jar into a wire, that phenomenon is identified as an electrical discharge in exactly the same way as if you see this thing. You don't say, well, now, what could it be? Here's four hypotheses. The only one that explains it is that it's electric. You see that it's electric, even though this is not a first-level concept. But once you have your concept and you see the instance, you see it. And the same is true of him. Once he has the concept of electricity, the behavior that he sees is electrical behavior. So it's not as though this is the only thing that would explain it. This is it. This is the only thing that would identify what it is. So maybe I misled you in saying I used the phrase as the only thing that would identify and thereby explain it. But maybe thereby explain is too much of a concession, and I should simply have said this is the only thing that identifies what he is observing. And that's, I guess, is a better thing, a better thing. So remember that when you write the book.
And so if somebody else came up and said, well, maybe it's something else that you don't know about that has those properties, that would be arbitrary.
There's no such thing as something else that you don't know about. If we don't
arbitrary.
know about it, he doesn't know about it, and it's a complete nullity. It has no meaning, and it has to be completely dismissed.
Right.
Now, if the person came up and said, there's something else you don't know about, namely X, and we have all this evidence from all these realms of human life about X, and X has these properties, and X would do exactly the same thing if there was a lightning storm and so on. Then you say, well, wait a minute. I got to look for what's the differentiating feature here. Either this is and X are the same thing. This is like Chinese and English. We have to translate back and forth, or there's a difference. And then you'd have to go ahead and do the difference. But nobody ever did that to Franklin. All they ever said is, well, how can you know, And they didn't say that then, only after they became PhDs. Yes.
Could you answer the question you posed yesterday about evil people making illogical fallacies and why it's rationalism?
I've got that right here. Wrong one. Okay, this was the... I have a couple minutes? You were 2 minutes too late, starting. The essence of evil is irrationality. The essence of being irrational is being illogical. The essence of being illogical is committing fallacies, logical fallacies. Therefore, the essence of evil is the commission of logical fallacies. Now, you say I call that rationalism. Obviously, I call that rationalism. That is wordplay and nothing else. Any such thought progression is completely cut off from reality. It's simply the transformation of one word into another, into another. This is pure Platonism. There's a bunch of forms, and you just jump from one to the other to the other. And of course, this commits grievous equivocation, but that isn't even the main point. The equivocation is on irrational, as one example, because irrational can mean using reason but misusing it, or irrational can mean not using it. So there's not even any distinction made here, and that's a typical of rationalists. They just grab on, and there's no distinction they can make because they're cut off from reality from any basis of making a distinction. And there's a big distinction between reason and logic. Reason is the faculty. Logic is the method. A child has an obligation to be rational, but doesn't yet know the method of being logical. So a child may be illogical and yet be 100% rational in the process because he doesn't yet know what those what logical consists of. So the idea of stringing together these words is ridiculous. It's a pure example of deduction versus induction. And that is, you start with a word, evil. But in this case, the person has a memory. An authority said that's irrational. That's Ayn Rand. She serves as the premise. Now, reason equals logic. They're both opposite to faith. And logic is a certain kind of process, and if you go wrong on it, which evil must, then that's called fallacy. So it's all just up in the air like that. If you learn nothing else from this conference or from life, it's better to have no mental process at all than to engage in that one, because that one gives you the illusion of clarity, thought, precision, connection, mental activity, when in fact it's a form of daydreaming which is very dangerous. It's a form of free associating, floating abstractions. Now, what would be an inductive approach to the question of the relation between evil and reason, and logic and fallacy? Well, how would you do that inductively? Come to a conclusion about the relation between evil and these other things. You would have to look at some instances of evil, and you'd have to analyze what is actually going on in those instances. And then you have to say, can I generalize? Is there some concept by which I can identify what I observe and thereby make a general principle, which would require you to integrate your observations into a whole conceptual framework? Now, I can't do all that for you now. Induction can't be done, just in a quick chain. This leads to this, leads to this, because it involves everything. But just as a starting point, if I wanted to know the relation of the nature of evil, I'd take some virtue that I know and say, take independence. Now, what would evil or vice be in connection with independence? I'd think of a particular case, Peter Keating. Now, what is it he does that I would regard as evil or as irrational? Does Peter Keating go around committing petitio or stolen concept or, argumentum ad baculum? Obviously, that does not get to what it is he does. He's not walking around presenting fallacies, but he's a dependent. So what is the essence of what he does? When a question comes up, he looks to somebody else for the answer, as against what? He doesn't think. He doesn't exercise his mind. He does what other people say instead. So he halts his mind. He stops it. He doesn't use it. And if some fact comes up that conflicts with what other people say, he brushes that fact aside. He evades. So he walks around mentally, not thinking, but simply passive, out of focus, waiting for someone to give him a content, and then periodically deflecting some content. So what is the essence of what makes him dependent? Non-thinking, dropping consciousness, either not perceiving or actively looking away from the object of perception. It's a cessation of consciousness in that one example. Now you'd say, well, that's Peter Keating. You have to check, and you say, well, that's in the nature of independence, because independence is so and so and so and so. But that's not, is that necessarily true of all cases? What about integrity and justice and so on? And you'd have to concretize it. And then you'd have to go into what is the relation of thinking and virtue. And only when you knew the relation of thinking and virtue can you talk about the negative side, the relation of unthinking and vice. You have to integrate it into a moral system. And how do you know that thinking is virtue except by reference to a standard of value? So you need a whole code of ethics. That's here a whole conceptual framework. And of course you know that a conceptual framework in philosophy, ethics can't stand by itself. It requires epistemology and metaphysics, and those in turn grow out of science, etc. So you need the totality. That's just what I'm saying. The whole conceptual framework in relation to which you then say, I've surveyed all these various cases, I've applied this whole framework, and the essence of evil is non-thought. Okay? You would have no temptation in such a case to say it's a commission of fallacies. Because some people commit fallacies, and others who are just as evil don't even bother to cover them up with fallacies. They don't even go through an act for themselves. Dr. Ferris, doesn't bother trying to equivocate. He does for taking in the boobs, but to himself, he's quite willing, just to blank out and evade. So, do you get any idea from this the difference between these easy rationalistic floating along, which just has no content, no relation to reality at all, versus the tremendous challenge of an inductive approach, which when you have, you really know, and then you know what kinds of irrationality there are, and how does this relate to logic, and how does this relate to fallacies. The whole field is clear to you. I don't know, I've been stressing this now for, I guess, over 20 years. And sometimes I feel that I've got this point across, and then sometimes I hear a question like that and I feel it's hopeless. You can't get it across. So I'm trying again. I just hope that you get an idea at least that there's a difference, and that if you are sliding from one word to another without any mental concretes, without any individuals, without any concretization of what you're doing, it's just a little world of its own, it's wrong, no matter where you go, start or where you end. It has nothing to do with cognition, and it's very harmful to your own mental processes, to your own thinking. It's better to live and die confused than to try to untangle it by drawing little lines inside your mind that are disconnected with reality. That's the best I can say. So I guess we'll have to draw a line here. Thank you very much.